and good day, Algebra, the much anticipated part 2 of CO8. We started yesterday with talking about like a situation when you might use an arithmetic sequence, kind of what they're all about. And we also went through and identified each variable in the sequence. This being a key point, this can go on your help sheet. I highly recommend it does. This being under that key point section, all of these variable identifiers can go in a help sheet also, which again, I also greatly recommend. So just for recap, AN, this is our answer. It's what we're trying to find. So there's not really any variable value for that. It's what you're going to get, okay? But what does A1 refer to? A1, what are we plugging into the formula when we identify A1? Yeah, Lauren. The first term of the sequence, okay? It's what you start with. Yesterday when we had the time and distance table and the bank account, right? It was how much money was in our account at the start, okay? What the distance of the object was after 1 second at the start. What does the end variable represent? What does the end variable represent? Yeah. Don't go like this. Sasha. Yes. The number of the term we want. Okay? And how about the D variable? What does that represent? Maggie? The common difference. Okay? Also the pattern. Now yesterday, both the patterns that we actually looked at were patterns with addition. So our common difference was positive. Today we're going to look at some of them that are with subtraction. Therefore, our D variable is going to be negative. Okay. And just to read, I cut it off the top of the page here, but an arithmetic sequence occurs when you have that consistent pattern, that common pattern with addition or subtraction. Okay. So kind of actually going backwards a little bit, we jumped right to the word problems yesterday. We're kind of going back to just practicing what these variables are and what a sequence is. It says, write an arithmetic sequence of at least 4 terms using the given first term and common difference. So if A1 is 17, that tells us where we're starting, right? That's the first term of this sequence. With a D value of 6, Maggie B, what would our second term be? Anyone know? First term of 17 with a common difference of 6. What would our next term in the sequence be, Aiden? That's what the common difference, that's the pattern. If the pattern is positive 6 or adding 6, what would come next? 23, right? What would come next? 29. What would come next? 35. Okay, so whatever that D value is, that's just what's happening in the sequence. What are we doing? We're adding 6. Okay, D equals 6, right? So when you look at a sequence and trying to decide, what are my different variables for this formula, that D comes from what's happening in the pattern, okay? With a first term of -4 and a D value of -3, again, the first term is where we start, so it gives us the starting point. What's our next number going to be in the sequence? With a D value of -3. -7, subtracting 3. Okay? So here's our first example of where that D is negative, and all it means is that the pattern is with subtraction. Okay? Leah, what would come next? Connor? -10. Subtract 3, right? And what would our fourth term in the sequence be? Sarah T? -13. Okay. Last one, starting value of 5, a D of -11. What will come next in the pattern or in the sequence? Sasha? -6. We're subtracting 11. Then Oh, brother. Make the old guy. Connor, negative 17. And then, Lila, negative 28. Okay, so recognize that A1 value, that first term of the sequence, and then that D is just what's happening. What are you doing? Positive, you're adding. Negative, you're subtracting. Okay, so now in the next section, now we add N, right? And we're saying use the given information to find the nth term of the sequence, put the values into the formula to solve. So again, here's the formula. AN equals the first term plus, in parentheses, n minus 1 times D. Why do you subtract 1 again? Why in the formula are we taking that n value and subtracting 1? Like this first one, if we're starting at 6 and we want to find that 12th term, why do we subtract 1 from that? Right, we already have the first term, which means that our pattern here of adding 4, we need to do that 11 times to get to the 12th term. Okay, that minus 1 is part of the formula because you already are given the first term. You have 11 more to go to get to the 12th, right? So our first term is 6, okay? Our common difference is 4, our pattern, and the number of the term we're trying to find is 12. So in our formula, our answer will be the first term, 6, plus n minus 1 times 4. There's the formula. Put that into your calculator so you can practice entering it in and making sure you get the correct answer. Because you can use a calculator on this part of the test tomorrow. So practice putting it in there so you can do it the right way, get the correct result. Question, or do you have an answer? Question, yes.
So on the test, does it ask us to show our work?
On the test, as far as showing work is concerned, I don't require it. I do recommend it though, because if you make a silly mistake and there's work and I can see that you did the right thing but just calculated wrong, I'm much more likely to give you the point than if there's no work and I don't know how you got the answer you got. So work is beneficial because if you do make a silly mistake, I'm much more forgiving than if there's no work shown. Noah. Yeah, what? 50 should be what you get here. Okay. Anybody not get 50 and not quite sure why? You can enter this whole thing in your calculator all as one equation. You don't have to break it up at all. Your calculator is programmed to do the correct order of operations. Don't have to worry about that. Any issues? No? All right. Next one. Our first term is 4. Our D is negative 3. So this pattern is going to be with subtraction. And our n value is 80. So using our formula up here, our first term is 4 plus 80 minus 1. But this time, make sure you make your 3 negative. Okay, times negative 3. And what this is finding is starting at 4 and subtracting 3 over and over and over again, what will the 80th term of this sequence be? If we do it 80 times, 79 more times, what will we end up with? Who's got an answer they're confident in? Sasha? Negative 233. No, is that what you got too? Okay. Negative 233. Anyone not get that? Connor?
No, I have a question.
Yeah.
You have to put A1 equals negative 233 in the answer?
You have to, sorry, do what?
Is it A1?
Technically, it'd be AN equals, right? The A1 is the first term. It's where you start. That A1 gets plugged into the formula. It's not part of the, it's how you get to the answer. It's not what you're solving for. Yeah. Okay. Do the last one on your own here. Write the formula or plug it in. a first term of negative 50, a pattern of positive 71, adding 71, and I want the 101st term in this sequence. Question or answer? Okay, save it for now. Question or answer? Answer, save it for now. If you don't have a calculator today, bring one tomorrow. Okay, you aren't allowed to share calculators on a test. So if you don't have one today, bring one tomorrow. I have a very, very limited few that I have to give out, and they're different from the one that you probably normally use, and so you might not be familiar with it. It's kind of like when you go to take your driver's test. You have to bring your own car, right? And you want a car that you've practiced on, so you know where all the buttons do and everything like that. You know, you don't want to practice parallel parking in a smart car and then bring a minivan to the test. That would be, yeah. What are you gonna say? Did he? We don't know. Oh. Okay. The formula: negative 50. It's our first term. Plus, we want the 101st term, so we subtract 1 from that because we already have the first one, so it's 100 more times 71. That's what your formula should look like. What do you get? Noah? 7,050. John, is that what you got too? Do you have a second on that? Yes? 7,050? Yes? Okay. So if you didn't get 7,050, take a look at what I have written there. Make sure that you started with negative 50. Make sure you subtracted 1 from 101. Make sure you multiplied by 71. If you're not quite sure where you might have made a mistake, then raise your hand and I'll come around and take a look. Okay. The next section, it says determine if each sequence is an arithmetic sequence. If it is, identify the values of A1, N, and D, and then find the nth term. So the first one says find A12 of 15, 22, 29, and 36. First of all, is this sequence arithmetic? Is there a constant pattern with addition or subtraction? Yes. What is the constant pattern? You need to know that because that's D, right? Adding 7, so it's going to be a positive 7. Okay? What's our first term? What's our A1 value here? What's our A1 value here? Sasha? 15. We can see that's where we start. And what's N? We haven't come across this notation yet, but if it says find A12 of 15, 22, 29, 36, what do you suppose N is here? What did you guess, Connor? Very good. Yeah. This A12 means find the 12th term. Since AN, we said that was our answer, that N, is sitting right there, the 12th term. Okay? Let's look at the next one. I'll have you come back and finish this one shortly. Find the A101 of 1,024, 1,976, 952. Okay? Is this arithmetic? It's kind of confusing to look at all those commas in there, but is this arithmetic? Is there a constant pattern? And then if there is, what is it? Lila?
Yes.
Right. You're subtracting 24. So our D is going to be a negative 24. Represent we're subtracting here. Our first term, what do we start with? 1,024. And what number term in the sequence are we looking for? What's our N, John? 101. Okay, so we're going to pause the video. I'll come around, answer questions if it's entering into the calculator. But go through this section here. We got the first two with the variables kind of laid out for you. You just got to put it into the formula. The second two, decide if it's arithmetic. If it is, find the nth term. If it's not, then just no solution symbol will be fine. So we will touch base shortly. This. Okay. So plugging the pieces in here, we've got the starting term of 15, plus we're looking for the 12th term, so not n, 12 minus 1 times that pattern of positive 7. So this one should end up being, what, 92? Okay. The next one, where we are starting with 1024, that's our first term, plus n minus 1, 101 minus 1, times our common difference, our pattern of subtracting 24. What'd you come up with for that one? Lauren? Negative 1,000 what? Do I have a second on that? Yeah? Yep, good. Okay. Negative 1,376. That third one there, the 20th term of 7, 8, 10, 13, that is a pattern with addition, right? We're adding 1, adding 2, adding 3. However, why is it not an arithmetic sequence? What about that pattern of plus 1, plus 2, plus 3 makes it not an arithmetic sequence? Jacob? Right, it's not a consistent pattern. You know, plus 1, plus 2, plus 3 isn't consistent. It changes, boys, right? Like here it's minus 24, minus 24, minus 24. That's consistent, okay? So it's not that you can't find the 20th term. It does have a 20th term. It is a pattern. However, you can't use the arithmetic sequence formula to find it. So for our purposes, for this objective, it's going to be a no solution, okay? The last one, it says find A48 of negative 1, negative 12, negative 23, negative 34. Our first term is negative 1. That's where we start. The term we're looking for is the 48th term, and we get that from that A48 there. And our pattern, we are subtracting 11 each time. So our formula is going to be negative 1 plus n minus 1, or 48 minus 1, times negative 11. The 48th term of this pattern. What do we get? Sasha? Negative 518. Do we have a second on that? Anyone get something different? No? You got 518? No? Okay. All right. So, I mean, part of this, you know, if you forget the formula, if you don't make a help sheet, you don't write it down, you forget the formula, you could just subtract 11 over and over and over and over and over and over and over again until you get to the 48th term, right? So if you forget the formula, you do have an out. It's going to take you longer. There's more chance for mistake. It's not very efficient, you know, but you can get there by doing that too. It's possible, okay? We did the bank account question yesterday, but looking at the other ones here, it says on the first day of school, you bring a jar of 1,243 jelly beans, and starting the next day, eat 11 each day. How many jelly beans will be left in the jar after the 31st day of school? What's our first term? What's our A1? What's our N? And what is our pattern? What's our D here? Lauren, give me one of those three. The difference is 11? You're eating 11 each day. So what's happening to your total amount? Are you getting more jelly beans as the day goes on, or as the year goes on, or getting less? Less. So it's going to be a negative 11, right? Because our total is decreasing. Okay? Aiden, give me another one. Your choice. A1 or N?
A1, would that be 1,243?
Yes, it would be. It's where we start. Will, what is the N? What term of the sequence are we looking for here?
31.
31st. Very good. Okay. So putting this into our formula, we're starting with 1,243. Our N value is 31, so we subtract 1 from that because we want 30 more, right? We already have the first term. Get to the 31st, that's 30 more. And we're multiplying by negative 11. How many jelly beans are going to be left on day number 31? Noah? John?
913.
913. Do I have a second on that? Yep. Okay. All right. In the interest of time, because I do have to get your practice test out, we're going to skip the last one. But any more questions on arithmetic sequences? Okay. This can go on a help sheet. The formula, what the variables mean, all that stuff from the first page of this. Okay. All righty then. That's IMath.